Columbia, this is Sunnyvale. How do you read?
Fine, clear.
We would like you to go to panel L11 and watch the cover and its open LED.
Columbia, this is Sunnyvale. How do you read? Over.
Hey, you're very weak, so speak slowly, sir.
At 061730, their LED on.
Okay, and I should be looking for operation during this period, and if I see it successfully, you want me to leave it alone, or you want me to still go to override?
Roger, sir. We'd like you to go ahead and go to override in either case.
You're good enough to hold up these cameras. They aren't quite in the side of the mast, so during the burn, the camera holds these around. You got a beautiful picture of these.
Troubleshooting procedure for the getaway special.
According to my understanding, I have 1 more minute of this, and so far we've had no joy.
Alternate methods of anchoring oneself in weightlessness were praised.
Lack of gravity also has some disadvantages in that you must somehow anchor yourself if you want to work in space. Here, the crewman puts his toes under the edges of the locker, and notice he has quite a bit of freedom then to move about without coming loose and floating around.
Columbia, Houston, data on the capture and rigid ice looks good from down here. You are go for further operations.
On Flight 4, the Induced Environment Contamination Monitor was used to check for contamination in and around the payload bay, created by thruster firings, outgassings, and water dumps. 11 separate components of shuttle's induced environment were measured. The desk-sized monitor was the heaviest payload lifted by the remote manipulator system during the orbital flight test program.
We tried to activate the getaway special, and don't seem to be able to make it work.
Mission Control, Houston, 2 days, 6 hours, 20 minutes mission elapsed time. Ground controllers and mission control and thermal experts have studied indications that they're getting from the spacecraft as to the possible continued presence of water on the underside tiles, and decided to go to a bottom sun attitude again tonight to be sure that they have baked all the water out of the tiles to avoid any possible problems on entry.
It sounds to me like we owe somebody down there a great big cheer. Your little fix for the first try on fixing up the gas, and we got relay 02 and 00 shifted from latent to hot.
Well, that's really great news. You're going to make a lot of folks happy down here. Thank you.
Columbia's commander, Ken Mattingly, reporting during the Chagarty Pass that he has been successful in the getaway special repair, and that canister, experiment canister, is now activated.
It's right in the middle of our picture, TK. It looks great.
Yes, sir. That's a familiar sight. I don't know if you can see the SLF on your monitor. It just stands out like it was painted with a big arrow from here. Ken will sweep over and you can pick up things like Lego Kajobi.
Yeah, I think we can see the SLF.
This is Shuttle Control. Ken Mattingly gave us a live television tour of the Gulf Coast and of Florida, and of the flight and mid-decks of the orbiter Columbia.
An ongoing task on all 4 missions of the flight test program was to evaluate living conditions on board shuttle. Items included food preparation, use of a food warmer, a freezer on board Flight 4.
One of the things we took a look at in our operational evaluation was some revised packaging of the food system. In order to save weight and space on the spacecraft, we have gone to dehydrating the food, putting it in some plastic containers. Now, Hank is on the left side of the picture putting water in to hydrate it. You mix it up. Since most food tastes better if it's warm or if it's cold rather than ambient, we have this aluminum thing that looks like a suitcase. It's actually a little portable heater. Put the food that has to be warmed in there, and then we'll put it off to the side for 15 or 20 minutes and let it warm up. At the same time, we had a little refrigerator, which we carried for the first time on this flight. Then we could put beverages and things in there that would be cooled. And you put it all together so that you have a hot meal with cool beverages, and it goes a long ways towards making the food a lot more flavorful. And just as it does on Earth, having a good meal does a lot to bring up morale. And when you're working 15 and 16-hour days, that's important.
This is a food warmer, if you hadn't guessed. It's really not our traveling kit. See it turn?
That's affirmative.
What do you suppose that is?
Roger, we're assuming it's airflow in the cabin.
Oh, you get an A.
Guys, we really appreciate your patience with us today. Things got pretty hectic, and you guys really hung in there.
Sure appreciate you watching the store for us. You helped us out a lot today. At least, Mike, we may not have solved my problems, but we thought about them all in advance. We just looked at each other and said, uh-oh. At the time, you came up and called us because I said I wanted to wait for some daylight. Did you get my comment about verifying that the doors close physically and that without any problem, that it looked like it was the latch mechanism that caused our problem?
All right, we copied that comment, TK.
Stand by. Mark. Close. Okay, they close normally.
TK, everything looks good to us. You can continue with the normal procedures.
Okay, thank you, sir. The two monitors touched on the right over there, the TV monitors we use to monitor the TVs. To the left of that is the control panel. We control the autopilot. And there's the hand control that we use from the aft station, the one beside the vehicle from the aft station. George, this is a geologist delight up here. I never had a chance to look at the patterns in Africa before, and you can see the rifts and the fault zones, and you can see all of the various volcanic sequences and trace them. It's really complex and fascinating. It's very much what you see out in some part of the western U.S., but on a much grander scale.
Roger, TK. Wish we could be there. There is a chance of some thunderstorms over South America immediately following our next stateside pass over Venezuela, Colombia, and Brazil. If you have time, you might take a look at those.
Okay, we got some spectacular stuff down around Rio and Buenos Aires the other evening. What was that? Flight day 2. It was really dramatic, and I think we got 2 mags of that stuff. Henry we dark adapted the cockpit here and been sitting here since sunset. Trying to see what we can see when dark adapted, which is something we haven't had a chance to do much of. And Henry noticed that the obvious horizon is not the horizon at all, but it's the horizon of the atmosphere. And that he noticed you could see stars set through this apparent horizon and track it all the way down until it was occulted by the actual Earth's limb, which is nothing amazing to space-type astronomers when using satellites and all. But then I turned the payload bay TV on it, and Hank and I were able to pick out, he's looking at it visually, and I'm looking at the TV, and I was able to make a tape that records all of that, and it's really impressive.
Roger, TK, we copy. Sounds like fun.
This unique device, designed by a fellow astronaut, allowed the user to monitor his own heartbeat while jogging.
This is using the treadmill that we have on board. The harness that I have around my waist carries most of the load. The shoulder straps carry a small part of it. The bungees that pull down on that harness apply a load of about 160 pounds to my lower legs, which is about my approximate weight. So I'm really getting about a 1G load on my legs. DK got a good run on it this afternoon. We also caught some 16 millimeter of that. The idea of this device is to be able to keep up the muscle tone in the legs and keep the cardiovascular function in good shape such that during entry and also when we return back to the 1G and Earth, that the blood will not tend to pool so badly in the lower portion of the body.
One of the devices we liked the most on flight for improving morale was a treadmill. It works exercise works in space just like it does on Earth. Clears your thoughts and makes you ready to charge again. We had a harness that's attached to the lower torso, and those bungee cords there applied a force equal to the body weight. So your legs were seeing the same forces they would see in 1G on the surface of the Earth. This was a real morale builder for our flight, to be able to use this.
There's also a device that's, I've got a clip on my ear in which I can monitor my heart rate. The little device also keeps up with how many miles, if I get that far, I run or jog or walk or whatever you want to call it on this thing. It can keep time for me and how long I was on it. This morning I have calculated that I walked about 6,000 miles. So it's a pretty good device.
The third device we looked at are these little sandals with suction cups on the bottom. We evaluated this for several days during the flight and found them to be very useful. We probably still need to do a little more development on them, but the concept is sound.
We have a picture we'll bring back, and we're not sure who to dedicate it to, but if it comes out, it's a picture of Hank with today's update, floating from the middeck, and it makes a rather impressive roll of paper.
Yes, sir. We figured that would get us within field goal range.
All right, that sounds like the winner. I'm just teasing you.
Well, we figured we had 100 yards of paper, and we're on about the 30-yard line going in.
I thought you were going to amend to our summary at the end of the day that we had enough consumables for the remainder of the flight plus extension, except we would have to terminate early because we'd run out of teleprinter paper.
That is a concern.
Columbia, Houston, we've been looking around for something for you to do, but haven't been able to find anything, so we'll just let you finish your meal.
The spacesuit to be used for extravehicular activity on Flight 5 was tried on during Flight 4 to practice the procedure.
This is an example of donning the lower torso of a spacesuit. I'm wearing a liquid-cooled garment that provides cooling when you're outside. The pictures are taken inside an airlock that's in the back of the spacecraft cabin on the middeck. The airlock is something we've never had before. It allows you to go inside, and the hatch you're looking at is an exit into the payload bay where you have the vacuum of space. Inside, you can go in a shirt sleeve environment, don the suit, check it out, and then translate outside without having to depress the major part of the cabin. The purpose for this exercise in STS-4 was to prove that we had good mobility inside the airlock. And you've just seen me put my feet in a set of stirrups that are going to anchor my feet so that I can simulate opening the hatch into the payload bay. This was in preparation for STS-5, where 2 crew members will come inside, close off from the cabin, depress the airlock, and go outside to perform an EVA.
So interesting comments that might surprise folks. my shoulders doesn't seem to have changed a bit. This is a perfect suit fit. I could do anything with it.
Sleeping conditions were evaluated. Use of sleep restraints and a sleeping bag.
You guys been sleeping on the aft flight deck, and I've been sleeping in the mid deck.
Roger, we copy that, Hank.
I've been sleeping in that sleeper tray every night. I've been sleeping right along. That's the greatest thing going.
The RMS was utilized in 2 days of our flight. The RMS is a sophisticated device. It works very much like your own arm, in which the brain computes the drive rates for the different joints to make the arm do what you want it to do. In the same fashion, the computer computes the rates with which to drive the arm. Here we see an example of how you can roll a payload about its own longitudinal axis, yet not make it translate. You can do the same thing in a similar fashion by causing the payload to go up and down with respect to the orbiter, or we can make the payload go back and forth parallel to its own axes, as you see here, without rotating the payload. So it's a very versatile and useful tool. Here's a shot of an upfire in jet and side-firing jets. This is the kind of firings we took the data on, as I told you, with the plume survey. There's one of the small vernier jets firing. We took that picture from the elbow camera on the RMS.
It has a very bright, light blue arc next to the aerial wheel, and it has an orange surface, and the sun is just about to pop up.